Trig. How many degrees are there in a circle? 360. So this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees. Okay, go all the way around. All right, so let's say the radius of this circle equals 1. The radius of the circle equals 1. The radius of this circle and a radian are very closely connected. Okay? If I take this distance, which is the radius of the circle, and go around the outside of the circle, 1 radian equals the same length of 1 radius of the circle. So if I would take and measure with my ruler here, and where did my ruler go? Right here. Great, stole it. All right, so looks like my radius of this circle is 12 inches. So if I kind of wrap this around, that was really close. The radian, 1 radian, where did I set my computer? Is about right here. Now if I go around again, right about there. So right about, am I close? Yeah, right there. There's 2 radians. I go here. About right there should be 3 radians. Okay. So if I keep going, there's 4 radians. And I think 5 radians is about right there. Well, no. Oh, no, Mr. Bierschbach. Let's try this. That might be a little closer. 4. 4 might be more like here. 5 about here. 6 about right here. Okay. So there's a little left over here. About a quarter left over. Okay. Or it's about 6.28 radians to get around a circle. Okay. So get around half of a circle, it's, what's half of 6.28? 3.14. Ever heard of that number before? 3.14 is what? Pi. So it takes about pi radians to go 180 degrees. And it takes about 2 pi radians to go 360 degrees. Okay? Because what is the circumference of a circle? The circumference of a circle is 2 pi r. 2 times pi times the radius. So there's 2 pi radians in a circle. Okay? And in trig, we use radians a lot. Okay? So we have to understand the concept of radians. Okay? It's a distance just like degrees are a distance, a measure of an angle. So this angle right here might be, I don't know, 67.5, or it might be 1 radian. Let's figure out exactly how many degrees and radians, how that works. Okay? In 360 degrees, there's 2 pi radians. So if we divide by 2 pi, and leave the radians over there, 360 degrees over 2 pi is 1 radian. So we can figure it out that way. Or if we reduce 180 degrees over pi gives us how to convert from degrees to radians. Okay, 180 degrees allows us to convert from degrees to radians. Now, somebody take on your calculator 180 divided by pi. What's 180 divided by pi? And pi is 3.14159265, yada, 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 yada. But you have a pi button on your calculator. So what'd you get, Ella Malone, when you took 180 divided by pi? Did you find the pi button on your calculator? I bet it is right here. So if you go blue and that. Yeah, because I'm putting you under immense pressure here. 57.3. So this angle is like 57.3 degrees, makes 1 radian. 2 radians is like 114.6 degrees, about. If we add another 57.3 on there, that's 171.9 degrees, which is really close to 180 degrees. So there's 3.14 radians in 180 degrees in a half a circle. Okay, so we're going to use this a lot when we're converting from degrees to radians, radians to degrees. So if you have a 86 degree angle and you're told to convert to radians, (86 degrees times what fraction? Now, if I multiply by 180 over pi, I get degrees times degrees, which is degrees squared over radians. So what I need to do is multiply by pi over 180 degrees. That way the degrees cancels, and you're just left with radians. Okay? So you take 86 over 180. Now, most of the time, we're not going to multiply 86 times pi divided by 180 and get a decimal. Here, let's just do it. Let's just get the decimal this time, though. Okay, let's just get the decimal this time. So take 86 times pi, which is, I don't know, close to 300, divided by 180. I bet it's more like 250-ish. Divided by 180. And what do we get as a decimal to like 3 decimal places? 86 degrees is about 1.5 radians. Okay? 86 degrees is about 1.5 radians. Now, what we're going to be dealing with are angles that go into 180 a little bit better than that. So, it'll tell you to leave it in terms of pi. Okay? We want an exact answer in terms of pi. So, 60 pi over 180 reduces down. 6 over 18 is 1 over 3. So it's just pi over 3. Okay, it's simply pi over 3. That's how to convert to radians. If you have 240 degrees, it's 240 pi over 180, which is 24 over 18. If you divide them both by 6, it's 4 pi. over 3. If we have 75 degrees, five goes into each of these. Actually, I think 15 goes into each of these, right? 15 goes into 75 5 times. 15 goes into 180, I think, 12 times. Is 75 over 180 reduced to 5/12? So, we can convert from degrees into radians. Now we need to be able to convert from radians into degrees. So if I have pi over 4 radians, and I want to convert to degrees, I take pi over 4, and then what I'm converting to goes on top. So 180 degrees over pi is what I'm going to multiply. See how I flip this fraction upside down to get to this one, because I'm converting the other direction. If I want to get 2 degrees, I put degrees on top. If I want to get 2 radians, I put pi on top. Okay? What happens to our pi's here? I have a pi on top and a pi on the bottom, so the pi's cancel. We eat our pi's. Pi's are gone. 180 over 4 is the same as 90 over 2, which is the same as 45 degrees. So if I have an angle that's pi over 4 radians, it is 45 degrees. Let's say I have 11 pi over 12 radians. If I have 11 pi over 12 radians, and I'm going to multiply, I multiply by 180 over pi. What's my next step? Cancel the pi's. Those were delicious. Now they're gone. Now, 12 goes into 180, I think 15 times. So it's basically 11 times 15, or 165 degrees. All right. Got to know what quadrants angles are in. So if you have pi over 5 radians, what quadrant is it in? Instead of just guessing, we got a method to the madness here. Okay? We could, at this point, multiply by 180 over pi and figure out the angle, which is 36 degrees. What quadrant would pi over 5 be? Quadrant number 1. What if I have 3 pi over 2? Well, if I multiply by 180 over pi, the pi's cancel. 2 and 180 cancel, be 90. So that's 270 degrees. What quadrant am I in? I'm not in quadrant 3. I'm not in quadrant 1. Not in quadrant 4. I'm on the axis. I'm not in a quadrant. Okay, that was a trick question. I am on the y-axis. So I'm not in a quadrant. So this is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. So if you know your fractions a little bit, if I have 3 pi over 4, 3 pi over 4, would it be in between what and what? 3/4 is in between 1/2 and 1, right? 3/4 is like 3/4. That's in between 2/4 and 4/4, right? So 3 pi over 4, you don't have to convert it because you know it's halfway in between these two. So you're in quadrant number 2. Okay? But if that just doesn't come natural to you to think that way, then convert it to degrees and then figure out what quadrant it's in. Okay, now here's the next trick question. Okay. 22 pi over 3. What quadrant is it in? Oh, no. Couple different ways we could do this. We could find coterminal angles, which we'll do in a second. Or we can convert this straight to degrees and then find coterminal angles. Okay? So let's first convert it to degrees. So pi's, I eat my pi's. 3 goes into 180 60 times. 60 times 22 is, like 1320? I don't know. Help me out. 1320. Is 1320? You see that anywhere there? No, so we have to use coterminal angles to figure out what quadrant it's in. So, if I subtract 360 from here, I'm at 960. If I subtract another 360 degrees, I'm at 600. If I subtract another 360 degrees, I'm at 240 degrees. Hey, 240 degrees is there somewhere. Where am I at? Quadrant number 3. So, you can convert it to degrees and do coterminal angles, or you can do coterminal angles right away. Now, we will have a question on coterminal angles with radians, so most people struggle with this question. Okay? How do I find a coterminal angle? What did I do here? How many degrees did I subtract? 360. 360 is how many radians? 2 pi radians is 360 degrees. 2 pi. So, I need to subtract 2 pi radians. But I can't subtract 2 pi because this is a fraction, this is not. To subtract fractions, you need a common denominator. So when you're working with coterminal angles in radians, you have to figure out what the denominator is, which is 3. 3 times 2 is 6. So 6 pi over 3 is 2 pi. So write the denominator down first, figure out what the numerator has to be to make 2 pi, and then subtract. So 22 pi over 3 minus 6 pi over 3 is 16 pi over 3. Then if we subtract another 6 pi over 3 from that, we get 10 pi over 3. If we subtract another 6 pi over 3 from that, we get 4 pi over 3. And 4 pi over 3 is something that we could figure out on our unit circle. So 4/3, 1/3 is there, 2/3 is there, 3/3 is pi, so 4/3 must be more like down here. This is 4 pi over 3, which is in quadrant 3, which we said before. Quadrant 3 for that. Okay? Let's do another coterminal angles with radian measure. If we have 17 pi over 4, let's find coterminal angles for that. So I'm going to write down my denominator first of 4. What makes 2 pi? What over 4 makes 2 pi? What divided by 4 is 2? 8. So I'm going to subtract 8 pi from there. If we subtract 8 pi from there, I get 9 pi over 4. Is that bigger than 2 pi? Yeah. So I have to subtract another 8 pi over 4 to get on my unit circle, and that's pi over 4. Where's pi over 4 at? Well, if this is 0 and this is pi over 2, pi over 4 is halfway in between there. It's the same as a 45-degree angle. Okay? So this is radian measure. Okay? So you will have a bunch of problems just on radian measure, converting from radians to degrees, degrees to radians. And then you'll have some where you're finding the quadrant, and you're going to have a couple where you're doing coterminal angles. So I'm going to unleash this assignment on you, and then a little later we're going to talk about arc lengths and sector areas.